So now let's go ahead and work on how we write the code to delete an item from the tree if it has two children. So if the root.left is, really these should be all else ifs, but it should be mutually exclusive, but it's always best to be sure. So root.left is equal to, if root.left is not equal to null, and I have a right child, so root.right is not equal to null. Okay, then I have to, well, then things get really interesting. Okay. Let's see. What's going on here? Did I get an error? Oh, right. That you don't need to spell it out like that. Silly me. Okay. Otherwise, case 4, we have 2 children, in which case we need to find our next in order predecessor. So the way we do that is, I always forget, or I always seem to have trouble writing this, and I did not review this, so, but I know how to do it, so let's see if I can't do this on the fly. So the first thing I need to do is step to the right. So let's go ahead and find out what my next in order predecessor is. It is, let's see, root. So let's see, root dot left is equal to left subtree root, or we can do root of left subtree. That makes better sense in English. Root.left is equal to root of left subtree. So here we have a bit of a condition here. Oh, I have to say what kind of item it is. It's a node E. Okay, so first things first. So I went one to the left, now I got to go all the way to the right. So got to make sure there is actually something to go to the right to. So if so if the root of the left subtree, if its right subtree is equal to null, well, then I've basically found basically my successor. So let's create a node E successor equal to null. So we found the successor because I can't go any further to the right. It's equal to your left subtree. Okay. Else, if it's not equal to null, well, then what are we going to do? We're going to say node E, we're going to basically iterate through everything. So node E current is equal to let's say root of left subtree, because we know it exists. So another one to the right exists, but why not? Well, current dot right not equal to null. Well, the current dot right is not equal to null. And by the way, I'm going to have to go by this. I'm going to go back to this and fix this because I'm going to because you know there's actually a edge case where there's another edge case where we're going to have to fix. So right now we're going to keep it as simple as possible. So while there's not stuff to the right, current is equal to current dot right. So basically, while there's still stuff to the right, look further to the right, look further to the right, look further to the right. Okay. And then we'll eventually get there, right? Now, once we get over here, current, there is no more current.write, so the successor is equal to current. Awesome. So now, what do we do? Okay. There's a couple things we need to do. So there's basically two steps. The first thing is that basically, rather than just like straight up deleting this node, which makes no sense, what we'll do is that we'll just simply replace the value in here. Which surrounds the node. What are we going to do? Instead, what we're going to do is that instead of deleting the node itself, we're just going to delete the 5 inside. We're going to take the 5 inside of it and replace it with 3. So that's the first step. We're going to copy what's in here over to in here. Okay. The next step is then we have to actually delete this node, and that's easy. Why is it easy? Because we're deleting a leaf over here. So let's do that first step. So successor.item. So first is replace root.item is equal to successor.item. Okay. To take the item from our successor, put it into root. Cool. We copy that over. Now we have to delete the successor node itself, which means we have to tell its parent. And we did not keep track of the parent. So that's one of the things we had to go back and do. So let's go ahead and fix this again. So instead, we'll say, because we know the right over here exists, all right? Actually, first things first, let's go ahead and put this up here. So let's go ahead and do a node e parent of successor. Okay. I don't even think I spelled it right. All right, so successor equal to null. Okay, now if we got to this point where basically we went one to the left and then tried to go as far to the right as possible, except that turned out that we couldn't go right at all. We set the successor plus subtree. Well, it means that root. Okay. So what about the other case over here? What is parent of successor in this case? Well, node.current should be root.write because we know root of left subtree.write because we know that exists. We checked it exists over here. In that case, we'll say parent of successor is equal to the parent of that. And as current moves along, we'll do parent.successor is equal to current. Current is equal to current.write. And then in this point, well, it's not equal to null, advance it. So this will advance, and then current will advance 1, and then as soon as its next one is null, yep. All right, so that works out, and so now we can simply say that parent is equal to parent.write, because we're going left, we're going left, and then all the way to the right. So since we're deleting this node 3 over here, we want to set 2's parent 2's right subtree to be null. And that should solve it, right? Parent of successor. Okay, and that should solve it. Okay, pretty much, except there might except there's one subcase which I'll get into in the next video.